where was I? So what we're going to do today is we're going to do 2 design exercises. I'm just trying to look for my PowerPoint. All right, so what we're going to do, so everybody can see my screen? Just a quick yes would be great.
Yes, sir.
Yes, sir. Awesome.
Yes.
Okay, so what we're going to do today is we'll try and model, oops, wrong slide. We try and model this today. This was a very popular tower that's actually got built. It's called the Absolute Towers by Mad Architects. It's in Canada. And it's one of those towers that is actually built. So one of those early inspirations and adapters of parametric design. And since we all love twisting towers, it constantly appears in our, I think, educational endeavors. We'll touch upon that. Okay. So quick study, we discovered 2 things. I'll just run you through what the intent was. That there are two towers, there are twin towers. And the first one, we're going to be modeling this one and not the back one. This tower, what carried 56 stories. So from G-10 till 198. And the other thing that one notices is that the building plan is actually not an ellipse. The first was thought that once you look at the image, seems like it's just simple rotating images or ellipses. But essentially, it's not an ellipse. It's sort of like a derived geometry more in terms of an oval. So what we also gather is we can just get a brief idea of how wide it is. We can read 12 meters, 12.5 meters between grid 7 and 5, which is roughly the same extended out. So just to, before we begin, just to get an idea of what the geometry is. But how do you model an oval? So oval is not inherent to Grasshopper. In fact, oval is not inherent form as well. And this is a website we kind of refer to quite often. It's called Wolfram Math. And I think somebody asked yesterday, how important is math? It is important to understand principles, but you can always refer to websites like these to get the exact formula out. So what we discovered was that to get an oval, we needed a larger circle, a smaller circle, separated by a distance a. I hope everyone can see my mouse, right?
Yes, sir.
Yeah, okay. So you need a larger circle, smaller circle, and a distance between them to give you a potential arc on both sides. So, and also the rule for this oval is that small r should be smaller in dimension than the big R, and a should be less than the subtraction of the large R and the minus R. It's just to get this shape. These are the simple principles. We're not gonna worry about, okay, the only thing we're gonna worry about is this. So first step is to model, to get this geometry going, and the formula to get the y. So basically, if we get the y, we'll be able to get this radius, because this bit is equal to this. This is r, and all we need is addition. We will be able to get that arc. So our first problem for this project is to get the base geometry going. All right, so keep that thing in mind. I'm going to keep popping. Keep that thing in mind. Our first intention is to get the R, R, and the A. So load up your Grasshopper. And the first thing I'm going to do is I'm going to take in Rhino, I'm going to take a point and put it at 0, 0, 0. You can either open grid snap and go at the center, or you can just type 0, 0, 0. So put a point right at 0, 0, 0. Okay. So we know how to reference a point. On Grasshopper, we type point, right click, set one point there. By the way, I've tried to, this is a script that I've actually borrowed from an online teaching platform. I'll direct you there. Made some changes to it so that we don't have to worry about Lunchbox. I think some Mac users are having problems with Lunchbox. So this is pretty much simple transforming exercise, which I think we've kind of held a grasp of yesterday. So what do we need next? What we need is these three numbers, R, R, and A. So let's say we set our first R to 15. Okay, let's call it. So how do you change the name? You right click on slider and just say R. I'll copy this. I'll just change this to floating point. That means decimal, to a 2-point decimal. So I have more control. I'll just copy this again twice over. Okay, let's change this to small r, and I want this to be lesser. So what we know is that we need to keep the small r smaller than the big R. This one is A, and this has to be larger than the difference of these two. So let's keep it at, say, 20. Okay. While you're doing this, also a good exercise is to clean up your script. So something I constantly do is I'll use align. So you select all, and you'll have these little bars that pop up. So left align. This should be available in display, canvas widgets, and align. So it's nice to clean up because once the script gets complicated, there's too much to see. Okay, the next thing is once we have these numbers, it is easy to get us this formula. So we need to get this distance of y, and this is the formula. There are a couple of ways to do this, but the easiest and the quickest is expression component. Now you have to remember that Grasshopper also follows the principle of BODMAS. BODMAS is something that we learned in like not even high school, maybe in junior school. Division follows precedes multiplication, precedes addition, subtraction. So we're going to follow the same principles. So copy the formula very carefully, because parentheses is going to play a role. And there is a little square there. Okay, so we know parentheses. If we give parentheses, it gives you preferences. So this parentheses will mean it will execute something that's within that. This parentheses is before squaring it, it will execute this. And of course, this is a division. So let's just check this against our formula that we need. All right, so y is capital R minus small r minus a square 2 into x minus y. Right? Okay. There we go. The reason we're using so don't confuse yourself. The reason we're using x and y is because this will accept x and y. It is lacking a third input, so we just zoom in and you'll see a plus button show up. You add, and now it will accept 3 inputs. Our capital R is X, our small r is Y, and A is Z. So there we go. We're already getting an output. It is minus 15. Okay. So I'm just going to set this at 5. So first job done. We've got this guy. Now what to do with it? What to do with it is actually now to make circles with these radii. Okay, so quickly what I'm going to do is move this point down down the x-axis to get the point for the other circle. So how do we do that? Move, we learned yesterday. A unit, I want to move it down x-axis, so I say unit x. There. And I want to move this geometry. However, I want to move it down with a distance of a. So coming back again, the difference between the two radiuses, this one and this one, is a. And we know we already have a, so I'm just going to input a there. There we go. Top view. So we have our second center point. Okay, so we need to create circles. So first thing I'm going to do is create a circle. You could use circle CNR or simply use the circle command. It requires the origin and it requires the radius. Radius is here. Yeah.
So you said the difference between the bigger r and the smaller r.
Yeah.
So we have to subtract it so it comes.
No, you don't. You're already feeding it. You're already giving it. You're giving 3 values. Okay, I'll just this is important. So I'll do this again. You're giving it 3 values. These values are defined by yourself. Okay, you're feeding. These are what you feel like, to be honest. Okay, so you're feeding 3 values: r, small r, and a. So you're feeding it r, small r, and a. So you're already defining a.
Okay.
You're typing in what a is from day 1. So we've typed in a as 20. So all you need to do is feed that to the move component.
Okay.
Yes, that's clear?
Yes, sir. Thank you.
All right. Okay, so the next is, again, I'm just so one circle is made here already. The other one that I'm going to do is
could you please repeat, after we got the x, y, z, then what did you do? I went to do
this expression.
Yeah, after that, once we connect all of them to r, and a.
Okay, this is fine. We're comfortable with this.
Yeah.
Okay. So okay, guys, just follow along on this. We need these numbers eventually to get the geometry of the plan. That's our endeavor. We need to get this outer oval. We're doing all of this is because an oval command does not exist in Rhino. In fact, oval command is always fabricated. There is no nascent oval like an ellipse. So what we found online, and this I just found on Wolfram, is the formula to get a potential oval. For this formula to work, we need to input 3 values, r, a, and r, so that we can get this value of r or this value of y, so that we can get this larger circle or larger arc going. That's all my intention is. Okay. The luxury is that we can define what these 3 variables are. This one, and this one. Which are these 3 variables? We just fed it in. The simple rules we followed was Wolfram telling us that the small r should be smaller in value than the big R, and the difference of these two should be lesser than what's the size of A. That's all. This is just a mental math to keep a note of before we feed in the numbers. So we've given these three values. Now we need to use these three values to make the geometry. So first thing I did is I moved this point down x-axis so that I can get the second radius. This is the first radius, point for the first circle. And now we need a point, center point for the second circle. So what we simply do is move. I want to move it in x direction, so we get a unit vector x. How far do we want to move it? We've already fed it in as 20. So in move, in the translation vector, put x, and in that component feed in this 20. So your point, you'll realize the point has moved on the x-axis by 20 units. This is up to you to control. See, okay, so we've kept it at 20. It could be anything. I just know with these values this script works, so that's why I'm sticking to this. Let's make the entire script, and then we can come back and play with these numbers. Okay, right. So the next thing we need to do is create a circle. I'm going to use, you can find a circle in curve, primitive, and I'm using this circle. You can use either this component, or there's a circle CNR that exists. You can use this, or you can use this, whichever, but I'm just going to stick to the above one. It's simpler. It needs a plane, which I'm going to feed the point, and it needs a radius. Now, what is the radius? Radius, we're trying to create a circle at the origin. That means the big R is the radius. There we go. Okay. Now, we need the circle at this point now. So we do a similar exercise. We do circle. I can just copy this and copy it. Now the point is this one, and the radius is this one. Okay, so this is the circle with the small r, right? Okay. Okay, there we go. So to make the script work, so make the geometry work, we need the same circle on the other side. So either you can copy the circle back, or you can move the point in negative direction. How do you do that? I'm gonna.
So
Yeah.
I'm actually getting concentric circles instead of two adjacent circles.
Yeah, because you're not using the new radius. For this guy, the radius is small r, not the capital R.
I have used small r.
And have used the right point.
Yeah.
The right point after move.
Okay.
We've changed the the center point and the radius.
I got it, sir.
So make sure you're plugging in the right information.
Yeah. Thank you.
All right. So now I need to create a circle, this same circle on the other side. I want to create one here. So what do? I will just simply move this point on the other side. So if you remember, we move this point with a unit x. I just want to use the same value in the negative side. So I'll copy this, and the only thing I'll do is in T, I'll right click. In the expression, I'll go minus x, and we'll create a circle on the other side. So basically, you've just made the input negative. So because this distance is same as that distance. Okay, same exercise. Create a circle there. Geometry in, radius remains the same. So you get your two circles on either side. Now we did all of this exercise to get that y, to get this value, and we know we can get this value from this equation. We've already fed that equation, so we know that the value here is y. And what we need, just a second, annotate red. Okay, so what we did was we need this value y, right? This is R, and this is small r. And once we get this value y, we'll be able to just let me change the color. Once we get this point, we'll be able to get an arc which is kind of tangential to all of this on both sides. That's the whole point. Okay, so clear all drawings. Okay, so we have the value y here. We need to create a circle again. Z, Control V.
Excuse me. When I put the negative value, it became red, and like it showed that runtime error happened.
You just don't put negative, you put negative X.
Oh, okay. Okay, thank you.
All right, so you need to move this point down by how much? By this much. Okay, so again, you move, let's delete this first. You move this point down. This time you need the value of sorry, you need the vector of y. So I will give it unit y, feed it here, right click, remove this negative x, right? And how much do you move it down is by this, whatever this expression is giving it. So there, it moves it down by -21. Okay. Right. So at this point, now we create the massive circle. For the massive circle, which is going to cover this entire part, what we need is the radius to be this distance, which is this, and plus this distance, which is the capital R. So we bring in on the canvas, we bring in addition.
So can you repeat the last part?
What's the last part? What we need to do?
The moved point.
So how have we been moving geometry? So let's address the concepts here. We use whenever we need to move whenever we have a move command. So look at my canvas. It requires two things. Move requires an original geometry. What do you want me to move? And T, which is the motion, which is a translation vector. Show me where to move. So whenever you have this translation vector, basically needs an origin point. It needs a vector from like the icon suggests. It needs an origin point and it needs a final point. Or it needs a general direction with a value on it. So I want to now move this point down by a certain number. If I have to move it down, that means I am, if you notice at the bottom left of my screen, I have to move it on the y-axis. Hence, when I put in move command, I bring in the geometry that I want to move and I give it direction. And this time it is the unit vector in y direction. Say so, and you can get it by saying unit y. Okay, but as the name suggests, it's a single unit. It's a single unit of y. So you need to give it an amplitude. You need to give it a value, and that value is coming from here. So that's what we did. We moved that point. We moved that point down by the value y. Okay.
Yeah. Okay, sir. Got it.
All right. The next endeavor again is to make
Sir,
a circle there.
Can you just change the battery view to the names so that it will be easier? Thank you.
All right. So now what we need to do is get the larger radius, which is simply an addition of this value and this value, right? Now we know this value is coming from the expression. We feed it here, and this value is basically the radius of this larger circle, which is capital R. Okay, so Now at this point, we need to create the larger circle. So again, circle, circle. Which point? This point. So we feed the point. And what's the radius? Radius is this addition that we just did. Okay.
So doesn't matter which, like A or B, which one do we feed which R or value to?
It doesn't matter. It doesn't matter.
Even during multiplication, it doesn't matter.
It doesn't matter. No. Division, of course, it will, right? Okay. So if you notice, once I plugged this in, it made a shorter circle, while we were hoping that it will make that big guy right there. Okay. The reason is that this value is spitting out a negative value. It's spitting out a -21. So very simple. How do we solve this issue? I mean, again, basic math, I guess. Basic math, I guess. If you have -21, that value with a -1, and so you'll get a +21, right? So it's just simple understanding. So all we need to do is do that, get a -1. There are quite a few ways to do this. Again, you can put it in the expression. You could use multiplication. Simply, and make one value as -1. I'm just going to use a quick command which is called negative. And as the name suggests, it's just going to turn the value negative. So before this addition, I feed this, feed that, and there we go. All right, simple. So we get that circle.
So after doing the addition, there's an error popping up.
I mean, are you getting the right values? So in addition, you need to feed this guy.
Yes, sir.
And this guy.
Okay. All right. Yeah, got it.
Right, but when you feed this guy, you have to before you feed it, you have to turn the value negative, which is this component, negative component.
Okay.
Right, because this is throwing out a -21. We want a +21.
Okay.
Right. Okay. So now if you are on board, we should be able to get these circles, these 3 circles. This circle is only just for reference. We don't need it, so I'm going to turn it off. I don't need that guy. Okay, and similarly, I need my 4th circle.
Sir, I have a small doubt.
Yeah.
So is there any battery that if you give the input as minus or positive, the output must be only positive?
If you multiply a negative with a negative, you'll get a positive, right?
So I mean, so in case of multiplication, if I give a negative value, or if I give a negative value, it turns to be a positive. So if I give a positive value, it turns to a negative, right?
I mean, no. So basically, I mean, positive negative will make a negative, positive positive will make a positive, and a negative negative will make a positive.
Yeah.
Right. So if both in multiplication, if both the numbers are negative, you'll get a positive. If one is positive and one is negative, you'll get a negative.
Yeah. So my doubt is like whatever the input may be, negative or positive, I just want a positive value. So is there any battery kind of that for that? Or we can do some basic math and solve that?
Yeah, you just do basic math and solve that. It's not a big deal. Just put it in an expression, or just keep a multiplier ready, or just like here, keep it ready in a expression. It's just simple stuff. It's not nothing to worry about. Yeah. Rhino does have a complete positive called mod and stuff like that, but rarely used. I mean, it's there, so you can use it, right? Okay. So we need to create this. To create the oval, we need this this circle to appear on the other end as well. That means we've created one part. but what we need to create is also this part, which is basically the same circle, same circle created at a point which is a mirror of this dimension, right? So this dimension has to come there. We need to get this point and get that circle again. Okay, so I'm just going to clear the drawing. So as some of you might have guessed it, it's simple by moving the geometry again, moving this point again, moving this point up, and we can simply do that by expression -2 into x, minus x, sorry. There we go. So it's moved up, and I create the same circle again. This time the radius is already calculated. There we go. So okay, so understood. So we needed to copy this circle up. We can do it by two methodologies: either copy the point of origin, center point, and then make a circle, or just simply move the circle. I chose to do the former. I copied this point there by moving, and I created a circle there. Okay, now our whole exercise is, now we've got the whatever Wolfram told us, we've got that. We've got this geometry going. What we really need is something to look like the plan. So this is the larger arc, and there is a little fillet there, and the larger arc continues and a fillet repeats itself. So that's what we're trying to do. We can get it if you visualize with me that that we pick this arc out, and we pick this arc out, and then we pick this arc out, and we pick this arc out. If we're able to do that, we'll get the exact geometry. So we have all the necessary ingredients to create that geometry. So we'll go, all we need to do, if I were to give you this as a CAD exercise, all you'll do is go around and trimming it. That's exactly what we need to do. We just need to trim the stuff that we don't need. And one of the ways to do that in Rhino is a command called shatter. And shatter appears in curve, in division, it's here, or like we've been doing most of the day, yesterday and today, I'm going to use a command called shatter. Okay. Oh, sorry, before that, my bad. Before shatter, I forgot that we need to calculate the intersections. So we need to, so there is something called, if you go in intersection, there is a physical intersection called curve to curve. So this is a curve to curve intersection. I'm just going to copy this down and use it 4 times. So what do we need to intersect? We need to intersect this curve with a larger curve, and this curve again with the other large curve. So this and this, you get, see, an intersection point will pop up. Again, the same shorter curve. That means this guy, but the different larger curve. So we get the 2 intersections on this end. We'll go ahead and repeat the exercise with copy these, Ctrl-C, Ctrl-V. Now I need the shorter curve to change in both scenarios. So there. So we needed these 4 points, 1, 2, 3, 4. I don't need the other points, so I'm just going to go back, and everything before before the circles, I'm just going to select all, middle click and turn it off. And this is a point that we created in Rhino. I'm just going to select that in Rhino and hide it. Okay, so we need to worry about these 4 points. Yeah, with me so far? A quick yes would help.
So could you just give us a minute? We're just connecting the.
All right, okay. Take 2 minutes.
Do we delete the point in Rhino?
No, don't delete the point. Just hide it. So you select
Hide
it
it.
in Rhino, and there's a command called hide.
Okay.
Okay, just hide it. It's just visual noise. We don't want it. If you're comfortable with it, you can let it be.
All right.
What's the likeness component?
Come again?
What is the likeness component?
What's this component? This component is called curve to curve intersection. In your intersect tab, it'll be under physical, this guy. In physical curve to curve. And what does it do is it, like the name suggests, it finds the intersection between two curves.
Sir, can you move the component a bit? The wires are kind of confusing.
Okay, man, no problem. Here you go. Clear?
Yes, sir. Thank you.
Understand? Okay, I understand the concept once. What we need to do is, if you were to trim it in AutoCAD, what will you do? You need to get the trimming point at these two junctions, right? So if you didn't select all and then just randomly start deleting this, what you'll do is you'll find these intersection points and trim this bit off and the behind of this curve, right? So that's all we're trying to do. We're trying to get the intersections. And how do we get the intersections? We want the intersection of the curves, the small curve with a big curve, and the small curve with the other big curve, and then repeat the exercise with this curve, with this circle.
So sorry to interrupt. I just have a small doubt. So basically,
Yeah.
hello.
Yeah.
So basically, why do we need to do all these geometric all these things in Rhino? It is, I mean, like in Grasshopper, it is better to do it in CAD or in Rhino so that the geometry is done so very easily. So to have to create a basic,
Yeah, but then
what is the advantage of this doing here?
You want it parametrically linked, right? So every time I'm going to modify the geometry in CAD and bring it to Rhino, then ask Rhino to pick up the geometry and then modulate it.
Okay,
it's a super long exercise. You just create it in one platform, so you kill the middleman.
Sure.
Yeah, does that help?
Yes, I get it.
So assuming, so for example, you're my boss and I come back with you this geometry and you say, Abhishek, no, I don't like it. Why don't you change the radius of the original guy to 17?
Yes,
and
yes,
then I bother you in the evening and say, 17 and a half. Next day there'll be a murder warrant against you in my name. So
yeah.
Okay, are we all here?
So just a second. I was a little held up at the point where we put the thing in the expression, like when we made the second circle, the bigger circle. Yeah, down there with the move command. Yeah, the expression thing which we put there, sir. Not there. The one below, move. Yeah.
This one?
Yeah. What was the like the formula which we applied at the expression thing?
Oh, here's the formula is written in the expression.
No, sir, like minus x or minus 2x, because I'm getting a circle.
Minus x.
Okay. But I'm not getting the circle above the thing. So it's getting slightly diagonal. The bigger circle.
Are you in top view or you're in perspective view?
Top view.
Is it a unit Y you've used?
Yeah.
You've used a unit X.
No, I've used unit Y.
Shouldn't happen. If you can just, I'll just keep this on for 2 minutes. If everybody can just copy this exactly.
Okay, 1 second. Yeah.
Yeah, I'm just going to leave it on for 2 minutes. Okay. I'll be back in a minute. Just take a look at this.
Yeah, I got it, sir. Thank you.
Sorry, I wasn't there. Say what?
Yeah, I got it, sir. Thank you.
Okay. All right, guys, let's move ahead. By the way, there is no lunch break today. So like me, you can just get in your bowls or your chapatis and eat simultaneously. And if you hear me chewing, I apologize. So the next thing we're going to do is we need to trim them. So like I said, there's a command called shatter that we'll use to trim. And what shatter needs is it needs to be told which curve to shatter. So first of all, we'll shatter this curve. I'm just going to pull this back. Which curve to shatter? So I need to shatter this curve. So I'll put this curve in. Okay. Now, what this component gives you, if you notice, is TA and TB. It basically means that this particular intersection point can appear on both the curves. It can appear on this curve and this curve, right? So how do you choose which one? TA means the point appearing on curve 1 or curve A, and TB means simply the curve appearing on curve B, the input that you're given. It's as simple as that. So we know we want to use TA because this curve appears in input A. Okay, nothing will happen so far. And also you need the other point as well, because if you trim it, you can't trim a circle with a single point. It'll just disappear, right? So where is the other point? It's this one. So you press shift and drag it there. So now your component has been trimmed. Of course, we can see both the trimmed parts together. So essentially shatter is behaving like a split, not necessarily a trim. So next thing I'll do is, if you put in a panel, and you need not do it, just look at this. If you put in a panel, it says it's got two components to it. We don't know whether we want the arc or we want the elliptical side. So how do you identify an element in a list? You simply have something called list item, and you can also get it in sets. Under set, there'll be something called list item. You feed a list in this, and if you notice, it is selecting the curve we don't want. So all you have to do is currently the value of the index. So remember what just happened? Sorry, I'll just a second. I just lost my power. Okay. So if you remember the data matching from yesterday, the data is always stored finally as indexes from 0 till whatever value, 0, 1, 2, 3, 4. Currently, this is set to 0. That's why once you select, it is selecting this one. So clearly, what we want is number 1. So all we do is we say 1 and put it here. And now we get the curve we want. Okay, so we got this curve, great. We'll try and repeat this entire exercise with the other curve, Control C, Control V. The other shorter curve was, which one was this one? Yeah. Other shorter curve, we feed it here. Again, the same idea, Control C, Control V. Now, wait, what just happened? Just a second, I made a stupid error. Let's do shatter again. The curve we want to shatter is this guy, right? We want to shatter it with this circle. That means this intersection, and we need a TA from here and a TA from here, right? Okay, so those little commands, what did I do? What I did was the same idea of shattering this curve. Again, I need to shatter at the intersections. So I put in a command called shatter. I feed this curve output to this curve's input. Now, what you need to decipher is again to use which T, TA or TB. Like I mentioned, this point can exist on the smaller curve and the larger curve. Since the smaller curve is fed into A, we've used TA in both scenarios here. And again, this was giving you two outputs. It had an arc-like curve and an elliptical curve. We don't know which one we want. So we do a list item, and list item by default setting of 0, it's giving me the desired arc. So we go ahead and repeat the exercise for the larger curves as well. So shatter. Which one do we want to shatter? We want to shatter this big guy. We want to shatter this big guy with at here at TB and here at TB. Okay. Control C, Control V. There we go. Very nice. And we need to repeat the same thing again. Go ahead and copy this. This curve. Disconnect all. This curve is this one. Point is this T B, and this point. No, this point is T B. That should give me. Oh no, wrong one. Oh yeah, so I can just. Yeah, so 1, 2, 3, 4. These are the 4 elements I wanted. I'm going to move this aside so you can take a look what's happening. And if you can just do me a favor and copy this completely. And I'll wait for 2 minutes. This wire mesh becomes extremely tricky. So my advice is just to understand, the logic, and you guys will be much more comfortable. If you understand the logic, you'll be able to solve this quicker. And in any case, I'm going to share, like yesterday, I'm going to share these scripts by the end of the day. So you will have the right script. You can choose to just follow along if you like right now.
Sir, a small doubt.
Excuse
Yes, please.
So may I?
Like your voice is cracking here.
Can you hear me now?
Yeah, yeah.
So with regard to the curve to curve, I'm not getting the TA and TB, the parameter A and B part, sir.
You're not getting this?
Yeah, the TA and TB part. So why do you connect the TA to that kind of a shatter?
Oh, you're not understanding. I thought you're not. It's not there in your component. Okay.
No. I'm not understanding it.
Okay. So simply, when two curves intersect at a point, right?
Okay. Yes.
That point is actually appearing on both the curves. That's right. Because
yes.
that point exists on both the curves, right?
Yes.
So
sir.
how do you know to take which point? The one lying on the smaller curve or the one lying on the larger curve?
Okay.
So T and TB are just that the point lying on curve A and the point lying on curve B.
Okay, sir. Yeah.
Okay. So the curve you feed into the shatter, that is the TA that you want to pick up. So in this case, see, this curve is going into A, right?
Yes. Yes.
And that is the curve I want to shatter. So hence I use TA.
Okay.
Right. This curve again is going into A, and that's why I've used this TA again.
TA. Yes.
Press shift and put it into this again.
Yeah.
So because
I get that.
right. So
Yes,
because
sir,
to train you need 2 points, right?
Yes.
So that's why you give shatter 2 points.
Sure, sir. I got it now.
All right.
Thank you. Yeah.
Okay, guys. 1 more minute.
So we can't hear you. I think you're on mute.
Oh, sorry, didn't realize. I made an error. Okay. Oh gosh. Okay, I made an error. Just change few things. The earlier what I had done was in this last shatter, we had used TB from this component, but we need to use it from this component. So disconnect that. How you do it is right click and you find disconnect. and when it turns red, you disconnect. So you disconnect this TB to this T from this TB from this T, and connect, hold shift and connect this TB here. And then the second mistake I made was, yeah, the I, you don't need that 1. You can just delete it. Let it be on 0. So by virtue of doing this, what you'll get is, turn everything off, is this guy. This is what we needed. So you got a final geometry. Okay, is everybody getting this geometry, please?
Yes, sir.
Yes.
Okay, go back and feel free to play with, remember these values and but play with it. You'll see the magic you can create. So get control. The first one is making our profile fatter. The last one is making it longer, but the middle guy is the crazy guy. It's creating from 1 geometry to 2 geometries and so on and so forth. And then intersection. You want to avoid this situation, this intersection, but anything before that is great. I'm going to go back to my original values. Okay. So we are here now. All we need to do is, we don't need to keep it separately into 4. We need this as one curvature. Then there's a simple command called join curves. And I take the output and just simply press shift and add all 4 of them here. We can turn this guy off as well. And now we just have to work with this join. So that's the first set in this entire exercise. We got the geometry. Great. Now we need to rotate it. So coming back, what we've managed is we managed this first plan, and now we need to create all the others. So we managed to create this now. You have to create all of these now. Okay, just about organizing Grasshopper. Make sure you're aligning your components. The stuff that is, they work together, you select them, align them left, right, whatever. You can equally distribute them. Just make it look clean. I prefer it a little compact as well, but of course it gets messy with the wires, but that is something that you can drag out and improve. Another good habit is I will select all of this, press Ctrl G and keep it in a group, and I will rename the group. There are 2 ways to do it. Right click anywhere in the group, right click, and you can give it a name, and I'm going to call it base geometry. Okay. The other one, which I like, once your script becomes this big, imagine you have these multiple chunks. There's another thing is that I call, what you can recall is, it's called scribble. So scribble gives you this little title tag. So in this, just say base geometry, and you can change the size to really big, say 40. And there we go. So even when you're zoomed out, you can see what's going on. Okay. So next thing we need to do is start rotating this guy. So a simple advice is shift to your perspective mode. So double click on your top view, double click on your perspective, so that you're able to see the numbers as they go up. Okay. A small idea that I follow is I'm going to start the next segment with a curve, CRV. And the only purpose of this curve is to store information that we created earlier. So all I'm doing is pulling this out, feeding it here, and turning this off. So for me, this bit is done. This is packed and done, and I've taken the final output into the starting point of the new segment of the script. Okay. Now, one thing that annoys me is this little tail that this component has. So it's a quick fix. You right click and you go to wire display and you turn that into hidden. So anytime it's not selected, you won't see that wire. Only once you select it, you'll see where the wire is leading you to. So just hide the wire. This is just, again, like I said, clean up your scripts. Okay. So let's start making floors. So let's say your floor to floor height is 4.75. And we know for a fact that this project has 56 stories. So double click and type 56. So these are your stories, and that is your floor to floor height. Where it's written slider, you can right click and rename. So I'm just going to say F to F HGHT, floor to floor height. And this is going to be number of floors. Okay, so we have that going. What do I do with this? I will create a series of numbers. So I want Grasshopper to give me like this math altogether. I don't have to I have to count every time. I just want it to multiply 56 into 4.75 56 times. So I'm going to create something that's called series. So what does series need? It needs the first number. We're going to keep it at 0. It's asking for a step size. Step size means what's the difference between the two numbers, which is floor to floor height. And how many times do you want me to run it? Of course, run it as many stories there are. So you've got series. Now, technically what has happened is that this has all your floors and floor heights, and this is your base plan. So all you need to do is copy it 56 times. So what you do is you say move. Like I had mentioned yesterday, there is no copy. Move, every component is basically creating a copy of the previous guy. You feed it the geometry that you needed. It's already got a translation vector of 10. Say unit Z, and just feed it the series. There we go. Yeah, everybody should be here. I'll give you a minute. I'll give you a minute. Okay. Moving on. Now what we know is that it's not a simple copy. It's a rotation while copying. So that's our next problem. So for again, good practice of Grasshopper, please do this. Select these guys, Control G, and call it copy base profile, or whatever you want to call it. Just get in the habit of grouping things together. Okay, so let's try rotate. What does rotate mean? Rotate means it needs a geometry, it needs an angle, and please read carefully. It needs angle in radians, not degrees, and it needs a plane, which is the XY plane. Okay, so geometry, we know we need this guy, simple. Okay, and there's a prefed angle that's already there, which is 0.5 by pi, whatever that translates to in degrees. Doesn't matter to us right now. What we know, however, is that this tower goes from -10 to 198 degrees, -10 degrees to 198 degrees. So if you remember yesterday, we know our bounds. So let's type in -10. Oops, sorry. -10 will not appear this way. So there's another way to get us number slider. I will say -20, -10, and say 200. So this is another way to get a slider. What happens is that if you put in a slider this way, you're already defining what should be the minimum value of the slider. The second number is the value that you want to start at and what will be the final value. So you start -10 and you can simply copy it and change it to 198. You can either do it by moving it or double click it and just typing the value. So you know you want the angles to change from -10 to 198. Comes in our little remap guy that we did yesterday.
Could you repeat the slider part? Like from what number to what number did you take?
Okay. Do you remember the angles that we need? The rotation?
Yeah. Yeah.
-10 to 198, right?
Yeah.
Right. So we need basically a slider to go from -10 to 198. So what we've created is how to create a slider. So there is multiple ways to create a slider. One is you click in the middle and you say 5. By default, when you say 5, the slider gets created between 0 and 10. If you say 0.5, it gets created between 0 and 1. If you say 15, it gets created from 0 till 100. And if you say 115, it gets created from 0 till 1000. Okay. What we want is a custom range. We want -10 to 198. So one method is you create a slider, double click on the slider, you go to minimum, and here you type what's the minimum you want. You want minimum as -10 and you want the maximum as 198. Okay, so now this slider will go from -10 to 198. The shortcut to create the same thing is that you double click on the screen, you say -10 less than 10 or whatever you want to create a value, say 5 less than 200. So this slider by default, instead of following 3 steps to get the desired result, just gives you the range -10 to 200 and the value to start with. But we know in our case the value is -10. Okay. Yes.
Yes.
Okay. So we need to remap the numbers. What do we need to remap the numbers to? What we need to do is every floor as it goes up, it has to rotate a certain amount. A simple method would be that I ask you, okay, subtract -10 from 198, you'll get 208, and 208 you divide by 56 is the degree of rotation for every floor. Simple. That's what you need. So you need to remap 56 values from -10 to 198. Is that concept understood? Little feedback, please.
Yes, sir.
All right. So how do we do it quickly? What we do it is we put in another series, and this time I will leave the start point and the step count to default, and just copy this here. Okay. So it has 56 values, 0 to 56. That's exactly what we wanted. And we want the bounds. Because if you remember, the remap requires this. It's not for any other reason. The component that you're going to use ahead requires this. It requires the values, the bounds, and the new bounds. So the values are this. The bounds is the range, the minimum to maximum. You connect this, and then you have the new constructed domain. So how do you construct a domain? Construct domain. Okay, so now you have a bunch of numbers being spit out, 56 to be precise, all of them from -10, notice there, till 200. But we don't want 200, we need 198. Okay. So now it's spitting out numbers. So every floor is being rotated, -10, -6, -2, 1, 5, whatever, whatever, whatever. Each floor is being remapped by a degree, by a number. Okay, what do we do? So these are, we've got our degrees. We've got our numbers that represent degrees. But this guy requires an angle, but it requires a radians. A simple fix, there's a command called radians, which simply converts your degrees to radians. So no fuss here. Join these and voila, you get your tower. I'll just hide the copy. And there's your rotating plans. Okay. And now it's completely parametrically linked up till now. So you can play with the floor to floor heights. It's going to become taller or shorter. You can play with number of floors. It's going to become taller and shorter. You can go back and play with this guy. It becomes 2 towers, fatter tower, longer tower, whatever. It's all parametric linked. So you change one value and you arrive at whatever you needed eventually. Okay. Good so far?
Awesome.
Yes, sir.
Right.
Yes, sir.
However, the problem with this rotation is that this rotation is very linear. And I mean that, you know, every floor is getting rotated by almost the same amount. It's a simple divide. What if we wanted a little more control over this rotation? What if we wanted like a preference to views? So maximum apartments get a preferred view. So we want to control the rotation a little better. So how we're going to do that is I'm going to introduce you to a concept called graph mapping. So you can leave this aside for now. What graph map, so you double click and say graph mapper, this one. And first thing you'll do is right click and go to graph types and choose any of these, but I would suggest to use Bezier. I will take my output of remap, that is the degrees, into this. And currently you'll notice oh, okay. One more thing I need to do here is double click on the graph mapper and now change the bounds. So we know this is supposed to be -10. This is supposed to be 198. And for Y, same, -10 to 198. This I got by double clicking the graph mapper, and you change the bounds. -10 to 198, -10 to 198, which is the same degrees that we want to that we've learned that the plans revolve on. So if you notice now, by doing this graph mapper, if the line is cleanly straight like a diagonal, your numbers do not change. So why the headache? But the game starts evolving once you take the middle guy and start pulling and pushing it. It is still operating from -10 to 198. However, you've got control over which numbers it can increase suddenly and it can slow down the rotation at certain points. Okay. However, what's the purpose of this? So let's type rotate again. Rotate needs geometry. I'm going to give it geometry. It needs the angle, and we know it. We have to get it from convert our radians. that now we feed. Okay, let's just hide this, and now notice the difference. Now when I play with the graph mapper, the rotation is in my control. Where do I want it rotated maximum is up to me. I can make a sudden jump at the top floor. You know, I can have larger orientations to the base and then make a twist at the neck. So you're in complete control of how do you want the rotation. It's still rotating from 10 to 198, mind you. So that's the advantage of a graph mapper. Now, if you can try changing it, you right click, go to graph types. You can try a parabola. Then it becomes even more wild. There we go. Okay. Right. So you play with the different kind of graphs to get different geometries. Right click. I'm just going to go back to Bezier. Let me find that example which I. Oh. Okay, Mad Architects. That's the company that made the tower. They are famous for, of course, Absolute Tower, but they're coming up with another tower in Shanghai, I think. Let me see if I can find that guy, which is very similar to Absolute Towers. Okay, I can't find it. I'll find it and show it to you. So the only thing I was trying to establish was that basically the other tower looks even crazier than this, but the only difference is probably the graph mapper that used. It looks crazy like this, but you know what's going on now. Are we here? Is it clear?
Yes, sir.
Yes.
Yes.
Okay.
Yes, sir.
I'll leave this on for 2 minutes. Let's just make it a group. And let's rename the group as what do we call it? Geometry rotation. Okay, just make sure you're here. Graph mappers look something like this, need not be identical. Shall I move ahead?
Yes, sir, I have a small doubt.
Yeah.
So what's the use of that remap? I really don't understand it.
Okay. So you have, let's say you have 50 stories, okay, and you want to rotate every story, and you want to rotate your base story to their top story, and the difference between 100 degrees, okay.
Okay.
So you want to go from 0 to 100 in 50 stories, right?
Okay.
Just sorry, who's asking this question, Vinod?
Yeah, it's me,
Yeah, okay.
sir.
So I'll talk to your image. So you have 50 stories and you want to go from 0 to 100. That basically means that every story will get a rotation of 2, right? That's right. It's a simple math, 100 by 2.
Yeah.
Right. What have you done here? You've actually mapped 0 to 50 to 0 to 100, right? But
yeah.
So your when it's in the 0 to 50 table, your value 1 is actually value 2 in the other table.
Yeah.
You value, say 16 is actually a value 32 in the other table.
Okay. Yeah.
Yeah, right? So you've remapped this list to this list, the larger list. You had this list, but you remapped it to the larger list, right?
Okay.
Right? But now this larger list is a vague list. It's like minus 5.783 to 5,324. Now what are you going to do? You can either divide again that difference by this, or you can just remap the values.
Okay. Okay. Fine.
Right? You're just making a correlation from this one to that one.
Yeah, sir. Okay.
Got it?
Yeah, got it. Thank you.
Conceptually understood?
Yeah.
All right, cool.
Sir, and one more small doubt. So how did you hide the lines in the battery starting curve name? Battery name CRV, that means curve.
Oh, here. Oh, okay, okay. So you right click closer to the button that you want to toggle with. There's wire display. There are 3 types: default, faint, and hidden.
Oh, okay, fine, sir.
This can work for anything. This can work for any of these guys. You just have to go closer to where the wire is.
Okay, okay, fine. That's it, sir. Thank you.
All right, guys, moving ahead. Okay. So currently it's a bunch of lines. Let's try turning this into a bit of architecture. So let's, first of all, let's make this entire thing into a bunch of slabs, because we all architects understand slabs, but for a product designer, this could be a vase again. But we don't want it to be a vase, we want it to be slabs. So one thing we'll do, let me save this. I haven't been saving today. Workshop chapters, outputs, tower. Okay, right. So you have all the curves coming out from here. You can simply turn the curves into a surface. There is in surface tab, you'll find something that's called boundary surfaces. So you drag that here, boundary surfaces, and you attach the geometry to the input. You've got your slabs. Now you want to give slabs some thickness. So simply let's extrude it. Extrude. Now again, back to the basics. What does it need? It needs a direction to extrude. We need to extrude it in the Z direction. I will feed this in here. It has given me slab thickness, but the amount will be 1 because this is unit. But let's say we want to make a flat slab and my slab thickness is 0.35 or 0.25, whatever. Let's see. Looks thinner to me. Let's just go to 0.3. Okay. And simultaneously, as I make slabs, I'm just going to hide the simple surfaces. Okay, everybody has slabs, and you have control over how fat your slabs are. Okay. Right. So simply what I'm going to do now is select this, group it, and I'm going to call my scribble and call it slabs. Okay, now let's make let's try and make the glazings from here to there. So what's happening currently is, if I zoom in, the curve is at the bottom of the slab, but I want to make a glazing from the top level of the slab to the bottom level of the slab above. So simply I need to move this geometry up by this distance. Move geometry, and all of this can be repeated. There we go. Right? And I can hide this guy. Is this clear what I just did?
So could you just explain again?
So what's happening is that, okay, let me turn this off. How I extruded the slabs was I just how I made the slabs was I just extruded the curves, right? But now now I want to create the glazing. So if you go back to the image of the tower, you know, these slabs extend out, and where is the slabs extend out, and you see the glazing is potentially behind the slabs. What you see is the railings, but the actual glazing is behind the slab. Let me see if I have another nice picture of this somewhere. Just a second. So yeah, so this is the slab, the glazing is back there, and there's a railing ahead. Okay, so I've extruded, we've done this white part bit, we've extruded the slab. Now I want to make the glazings, the facade of the main building. So clearly it's an offset, sort of an offset from the slab. That's the first thing we notice. But the second thing we notice that the offset is not consistent. It's larger here and it's thinner here. That's one thing to worry of. And the second thing to worry about is if I simply would extrude it from here, I'll have to cover the distance of the slab as well. Currently, do you know what I'm trying to say? Let me sketch it out and explain. Okay, this is your bottom slab and this is your top slab. Okay, our curvature currently, our geometry currently is sitting at this level, bottom of the slab level. I want to offset some part in, and I want to extrude this to make my facade. So I want this value. I want this value, right? All I'm doing with a little maneuver is move my curve, which is here. I'm moving it to the top of the slab. That's all I'm doing. So when I extrude, I just have to give the exact height that is required. I don't have to waste my extrusion of this amount. Okay, clear?
Yes, sir.
Yeah. Okay. So what I've done is I've moved this base green curve. I've moved it up. I moved it up. That's all. It was here. I moved it up. That's all currently. Okay. Now we need to offset this in. One convenient way to do this is scale. Scale. I can scale this in. How do we get the, remember, how do we get the center points? We get it with the area. These are the center points. This is the scale factor and 0.85. Now we are scaling everything in. You can see my screen. You can see the green curves. This is a scaled version of the periphery. But in the design, the scale is not equal. It's larger from this end and it's shorter from this end. So for that, what we're going to use is, it's called a non-uniform scale. Non-uniform scale, scale NU. Yeah, everybody got scale NU?
Yes, sir.
Yes, Okay, now let's see what it needs. It needs geometry. Oh, sorry, it needs geometry. Ugh, what did I do? It needs geometry. It needs scale X and scale Y. Okay, let's see. 0.75, 0.85. It is scaling, but if we're able to realize what's happening is that some places like here, it is closer to the edges. It's not scaling in the right profile. So what's happening with this scale is, okay, let me explain this again with a sketch. Annotate. Okay, what's happening here is that, assuming you have this as a rectangle and this is a center point, and once you scale it, it simply scales in. It scales in X and Y because your plane is X and Y, right? So it scales in Y direction and scales in X direction. However, once your geometry is this way, it's still scaling in this as an XY. So this amount, it's scaling in, but it's getting irregular now because the scale is not equal. Because this dimension is not same as this dimension. Are you with me? When it is rotating, when the tower is rotating, the plane should rotate as well. It should become XY this way. But if you keep it currently how the component is, the plane of the slab remains this way while the scaling is happening the other way. So that's why there is a little discontinuity in the scaling. So a quick fix to that problem. I think yesterday somebody was asking me about changing planes, while in the other orientation, this could be an example for that. So what do we need to do? What we need to do is call in a component that's called rotate plane. Rotate plane. It needs the planes to rotate, and you can get the planes simply from the center. And it needs the angle. We've already calculated the angle with the slider. It needs an angle with radians. So we're going to pull this out, put it in, and now everything is going to scale the way we want it. Okay, we did all of this exercise so that we could get control over scale. If you notice now, I can choose to be thinner at these edges, and I can choose to be wider at those edges. So whatever, that's part of the design. So let's just set this as 0.85 and this at 9.5, and here we are. Okay, we clear? Let's take doubts here. Any doubts?
Can you explain why did we use the rotate plane?
Do we use the node? Okay, rotate plane. Okay, fine. You notice how it's scaling right now, right? Notice how it's scaling right now. Okay, correct?
Yeah.
Okay, because my rotate plane is connected. What if I disconnect rotate plane? Now notice how it scales right now. There is something off because it's not exactly perpendicular to the original geometry. Okay, notice this and notice this. It realigned itself. So when we have a rotate plane, again in annotation, when we have a rotate plane, it is taking this true perpendicular plane for every geometry, for every plan. If we don't rotate the plane, what will happen is that this guy has a plan like this. The bottom one is actually has a plan like this. The below one has a plan like this, right? While the scaling is happening in one orientation.
Got it.
Got it?
Yeah. Thank you.
Okay. So that's why you need a rotate plane. Right. So we've got a base layer for glazing. We just need to extrude it. Again, the same principle. Extrude unit Z. And what is the height of extrusion? Where do we have the height?
Floor height.
Floor height, exactly. We have the floor height. However, we need to subtract the thickness of the slab, right? So simply what we do is we do subtraction. Floor height gets plugged in here. By the way, how you do that is you keep your left mouse, keep on dragging, and then you scroll with your middle mouse button, and then you subtract the thickness of the slab. And this is the geometry. There we go. So you've got your glazings. Right? So you have your slabs, you have your glazing, and you decide to have fun. You can still have fun. You change the geometry. You can see your output change every time.
So a doubt.
I lost you there. What?
Doubt.
Yeah, doubt. Okay, doubt.
Can we not loft the glazings here once we have created the offset for glazing?
Can't we do what?
Loft.
Loft to what? So now we're getting a little, so this way we're getting into a realm of little reality. Okay, so we can loft, and let me try and demonstrate what you're saying. The problem with the loft. Okay, so now currently what's happening is this is my slab, this is my other slab, and this is my other slab. My curves are lying here, 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 and I extrude them from bottom of slab, top of slab to bottom of slab. This is what I'm doing. However, if I loft them, we are forming a one continuous surface that is cutting through the slab. In reality, what's the point of that?
Okay. Got
right?
It.
What do we do with it? And once you're doing those complex structures like Pierre showed us today, this is wasteful information.
Okay. Okay.
Right? And in reality, of course, you're going to build floor by floor, right?
Yes, sir.
Okay. Valid question, though. Very valid question. We would be lofting it. If it was yesterday. Now we've matured.
Okay.
Okay, just a stupid comment. Okay. So we've got the glazing. However, this top guy is annoying. We don't need this top guy, right? We need to end with a cap. So all we need to do is we need to trim the list. So one way to do this little exercise is I'm going to trim this list is something called split list. Split list, which list to split this guy and which index to split it on. And index, again, we want the last number, which would be, so since we have 56 stories, that means the last number would be 55, right? 0 to 55. So that's it. Plug it in here. We split the list. And which one to follow? Let's see. Curve. Yeah. So look at this one. This leaves the last curve behind, and this B is actually just the last curve. So we need all the curves but the last curve, and that's what we're going to use for extruding. So we trim the top. This concept clear? We didn't need the last extra floor, so we got rid of it. We got rid of it by just changing the data that goes into extrude. How are we doing? Good?
Yes, so
Good.
Okay. So
Sir, I have a small doubt.
Yeah.
So what if we want to split the middle curve and split two middle curve? How can we do that?
You can't split the middle curve. You'll have to extract the middle curve. Suppose you don't want to extrude some, right?
Yeah.
You don't want to extrude, say, 23rd floor and 24th floor.
Yeah.
Right. So there is a command. There's a command called cul nth.
Okay.
So let's say we bring it here, and let's try this. Okay, let's put this geometry here, and I will. It says 2. I want say 23rd and 28th. Let's see what happens if we feed that in, and let's change this to that. There is, yeah. So these two floors. What is happening? You see these two floors, this one and this one.
Yeah.
Right? It's lighter red.
Yeah, I can see it, sir.
Right? Okay.
Yeah.
So it's called cul nth.
Thank you, sir.
All right.
What if we wanted to create like a double height space, like combining two floors so that the middle curve and the extrusion isn't there? Is it the same way?
So you want to create an atrium, right?
Yeah, sort of, yeah.
Yeah, but the thing is now in this, at least this methodology, remember the base geometry? If in the base geometry you're able to create an atrium, then you'll get an atrium throughout here as well. But in the base geometry, we kept it as a solid.
Yeah.
You with me?
Yeah.
Okay. So, okay, here's a little fun you can have. If you just create R, you play with R, you suddenly will see this guy will turn into a twin monster. See there? This can happen. Sorry, this is not an answer to your atrium, but this is just to elaborate that this manipulation is loyal to the original geometry we created. Right? If atrium is loyal to the original geometry we created, then you'll be able to create an atrium throughout. Basically, you need a puncture. So in this plan itself, we would have needed a predefined cutout there. So what we would have made was we would have made this outer oval and we would have made this oval. And then you follow the same procedure.
Got it.
Got it?
Yeah.
Okay. So that's the advantage of a parametric exercise. So like I was telling one of our friends here, if, for example, you and your team players are, making this project, and suddenly you come up with an idea of an atrium. So all you have to do is go back and change the base geometry, and none of this changes. Rest of this remains the same. If your logic is honest, all you have to do is tweak it here. So similarly, like everything, every little segment is independent, but it's parametrically linked. So one change here, you don't have to touch anything else. One change here, you don't have to touch anything else. Does that help? Okay. Let's move ahead. So we've got the railing, we've got the glazing. Now what else is there? There is a component of railing. So currently here they're slapping the railing on the outside of the slab. What I'm going to do is I'm just going to keep it on top of the slab, slightly inside, just to explain a principle. So where do we begin? We can begin with how we started the glazing, and this time we need not scale it non-uniformly. We can scale it uniformly. So get in scale, geometry, center, and we can just have a uniform scale of, say, oh, this is not sorry, Control C, Control V, and let's say a uniform scale of 0.95. So you've got your railings inside and you want to extrude it. So simple idea as before, you just extrude unit Z. It's a very high building, so I'm gonna give 1.24 feet of railing, and this is geometry. So we have the railing as well, and I want to give I just want to play with the railing, and I just want to give the railing a handrail. So what am I going to do? I'm going to move this curve up again. Unit Z. Actually, I have everything. What I need is here. Move this curve and there. So this curve is moved up. That's the handrail. Can you see? And then we just pipe it. Okay, let's say radius of 0.1. And there's the handrail. Okay, so what you guys have done now is we have a parametric tower. So we have the railing here. Railings here. We have glazings. And we have the slabs. So slabs, glazing, and the railings. This actually, both of these constitute two railings. So we don't need anything else before this. So everything else before that, you can middle click and hide. And we have what we need. And like I said, you go back, you have fun with these sliders and you can toggle. So yeah, just in whatever, 2 hours, you've all become the creators of absolute towers. Okay, encourage you to get good output. So let's continue with a little bit of exercise where how do you view. It will be nice to get quick images out. One thing that I would recommend is okay, let's for example give glazing a blue color and give slabs a concrete color or whatever. So there is something called custom preview, which we dabbled with yesterday, and for some reason I could not make it work. So custom preview, I'm gonna put this guy in, and let's say a material. In your display, there is a little shiny egg. Bring that down, connect that to the material, and in your KD, let's go through what different components is. This is this diffuse color. So those who've done a bit of rendering before, diffuse is the default color of the texture that you create. This is specular levels. This is emission levels. Emission means it's going to glow. Specular means there's going to be a speckle. Transparency and shine. So right click on your KD, diffuse color, and you have this little matrix. So you want to keep it a little blue. Let's say this. Done. So your glazing is a little blue. You want to add shine or any other thing, you can do that. Let's do the similar thing with your slabs. Disconnect. You have your change the color. Let's say we want to make it what's happening? We want to make it gray, so I'll just keep it in the center. It'll give me something gray like that. And we have slabs as gray, and we can have a different blue for the railings. Let's agree on a blue. Say a darker blue. There we go. So yeah, you get a just like yesterday, you agree on a nice view. Viewport properties. A lens of 32. Looking up to the tower. You can settle for a nice camera angle. Okay, what I would recommend you guys is if you would like to submit your work for Digital Futures, is get these screenshots out, montage it on Photoshop on a nice like a city background or whatever. I'm pretty sure you can easily replace this tower in Photoshop with your tower, the two towers. Sorry, where did it go? Yeah. So Digital Futures will be publishing some projects that get submitted by the end of tomorrow. So I would just, those who are interested, just let me know, and we can spend a little extra time on decorating it. Okay, so this is for parametric towers. Now, on paper, we've done a little exercise of master planning yesterday. We've done an exercise of architecture right now. And the next thing we're going to do is we're going to create surfaces, like a detail, where I'll try and sorry, I'm just trying to locate. Where did it go? Sorry, just a second. The last exercise we're going to do is is something like this, where we learn how to manipulate any surface to give it quad panels, diamond panels, triangulations, trusses, and custom geometry. So any geometry you need. So that's the last bit of exercise that we're going to do. Then I will try and teach you how to link all the 3 exercises together, so that tomorrow, primarily it's studio time, we can create our own little projects. So ideally, how I anticipate this workshop to go is that we create a master plan, pick up one of the plots to do this parametric tower, and then on the parametric tower, all these facades are actually not just simple extrusions, but it's a surface that you've designed. It could be a surface like, it could be a glazing pattern like this or any of these. So that is the whole endeavor. So I'll leave this on for a bit. I don't think you can read it. Let's leave this large bit on for 5 minutes. Let's take a short break, loo break, water break, and then we regroup, maybe to have a quick discussion, and we can get into those paneling exercises.
Sir, I have a small doubt.
Yes, sir. It's always a small doubt.
Yeah. So how can I change the autosave settings in Grasshopper? It's really
what
basic.
setting?
I mean, the time of autosave in Grasshopper.
Time of autosave in Grasshopper. I haven't done it in a long time. Let me figure it, Vinod, and I'll let you know.
Yeah.
Okay, I don't remember, man. I'm sure there's an option somewhere, but I haven't done it in a long time.
Because every time I mistakenly close the Grasshopper and forgot to save.
Dude, that's just a bad habit. That's nothing that a tool can solve.
Sir, can you show the first and the second part?
First part is this.
Yeah. Thank you.
Okay. Shall I just give you the script, guys?
Yes, sir, please.
Okay, I'll just give you the script. Now, where did I save it? Save document as. All right. I've just sent it on chat. Vaibhav Jain, where do you upload the code? You mean this code, Vaibhav, that I just gave? Yeah. Okay, cool. So yeah, let's just reconvene in 5 minutes. I'll catch you then.